This is a short video on multiplying and dividing algebraic fractions, that is, fractions that contain pronumerals. The first example I have here does not actually contain pronumerals, it's just a reminder of how fractions with multiplying work. So what do we have here? We have 3 multiplied by 2 and we have 7 multiplied by 6, because when we are doing algebraic fractions we can simply go straight across the top and straight across the bottom. However, you might have noticed that both of these things can now be divided by 3. So you could simplify this by saying, okay, 6 divided by 3 is 2, 42 divided by 3, have you got that one? 3 12s are 36, and you've got another 6 more, so that's 14. And then we look at that and we think to ourselves, it just keeps going, it's 1 over 7. Could we have gotten there without all of that simplifying? Let's have a look. There is a second method that I would like to have a look at, and that is identifying factors before you even start. See, this 6 at the bottom of this fraction could actually have been written out as 3 over 2, and then we can do something called cancelling. Now there's some rules with cancelling, and the rules go like this. You can only cancel something that's a factor within its own fraction, so it has to be multiplied into everything else in its part of the fraction, either the numerator or the denominator. Next up, when you cancel things, you have to cancel one thing on the top with one thing on the bottom. What you're really doing is dividing. So when we go to do this, I can cancel a 3 with a 3, no problems. What's left is a 1 because you're dividing by 3 in both parts. I can cancel a 2 with a 2. What's left here is a 1. What's left here is a 1. Now that I've done all that cancelling, I can go through and do the multiplying from the fraction. In this case, 1 times 1 is 1. 7 times 1 is 7. And that is a completed question. Let's look at our next questions. In this second fraction here, if we multiply straight across the top and straight across the bottom, we get 15 AT. Remember that pushing together the two pronumerals is a way of abbreviating multiplication. Writing AT simply means A times by T. Writing 15 AT means 15 times by A times by T. And then on the bottom, 2 times 4 is 8. I don't think there's any common factors there for cancelling. Let's move to the next question. We could go and multiply straight out, but we're going to get some big numbers. Let's have a look. 3 times 5 is 15. M times x is mx. Okay so far. 25 times 9 is 225. And I actually don't want to think about having to cancel 15 and 225. So this would not be my recommended approach for this question. I'm going to rub that out and start again. I can see here that I have several sets of factors that match. This 25 could be rewritten as 5 times by 5. This 9 could be written as 3 times by 3. And now that I've done that, I can do some cancelling. One of the 5's here can cancel with a 5 in the other fraction. So long as one's on the top and one's on the bottom, it doesn't matter which fraction they're in. One of these can cancel with one of these, so there's 3's cancelled, there's 5's cancelled. Nothing else cancels now, and I can go and put this all together. There's an m left here, there's an x left here, so I have mx over 5 times 3 is 15. And that's a lot easier than dealing with numbers as large as 225. On our next question, we have division. Now, the fundamental rule of division with fractions is that we don't do division with fractions. Instead, we multiply. We take our first fraction, we leave it exactly as it is. Multiplication and division are very closely related. I'm sure you've noticed that with things like 3 times 4 is equal to 12, but 12 divided by 4 equals 3. We could call them opposite functions. So if I turn the divide into times, I need to do a second lot of opposite functions in order to still be doing the same question. We talk about this as taking the reciprocal of the second fraction. The reciprocal is a very fancy way of saying turn the second fraction upside down. If we now go ahead and multiply the parts here, 14x over 5y, and nothing else there seems to cancel. In the next question, we have the same issue. We're going to write our m down, our 12. The divide turns into a times. We take the reciprocal of the second fraction, just turn it upside down. And then we look at it and we could either start multiplying straight away or we could do some cancelling. I'm going to do the cancelling. I prefer that much more than just getting large numbers. 12 times by 3, no, that's not what I'm doing. I am factorising 4 times by 3 in place of the 12, and I can cancel out those 3's. The m's cancel. Remember what was left on the top of each of these when I cancel everything? It's a 1 left on top. So now I have 1 times 1 on the top of that is 1, and what's left on the bottom? 4 times by 4. This whole thing is equal to 1/16.